And in today's live stream, we are going to be doing all different kinds of parallel homemade rate switch circuits. Yeah, so this is moving on power of this nature, 0.34.
Wow.
Yeah, like really low. And all of these coils are hooked up to the power supply, and they dump into this switch, and then there's one ground for it all. So it's easy to do. So many amps, man. So many amps. Oh my goodness, the amperage is like makes that like 2.5 watts. But the reason that is because the coils that are attached to this are 16 gauge coils and a 20 gauge coil. So automatically you're drawing a lot, and then the homemade switch makes you draw a lot more than like a normal switch or a transistor. You're pulling more amps with this way. All right, that's cool. And over here we've got probably a reed switch. We could probably do either one, reed switch or a transistor hookup. I haven't hooked it up yet, so we got options. I would like to use this though. The external trigger coil, sensor coil. We're gonna put it right there. And that should be pretty sweet. I just love how this thing is trucking right along at zero point 0.5 volts, zero point 0.2 amps. So like 1.5 right now. It's a lot. It's
Yeah.
a lot of watts for how low everything is. So we're at 0.66. We're gonna let it speed up, and then doing so the amps should drop down, and then I'll turn it up again.
So what kind of configuration do you have here?
Uh, it's a directionally oriented uh, magnetic field coil setup. So it pushes like this, like straight this way, pushes it that way, and it's pushing in the direction that it's going with the reed switch. So that's an added plus. It's the only way to do it, really.
It looks sweet.
Yeah, I like it. We're gonna call it. It's just I don't know, cocking the coil to the direction you want it to go.
Right.
Having the faces face the way you want it to go. And since I rolled all of these the same way, they're all gonna face the same way. Um, I rolled all of them from left to right and counterclockwise, so they're all the same. I thought that would be better for them to be, put together in this case like this. Let that pick up.
You can hear it trucking.
It's not going very fast, but I'm pretty sure it's got some torque to it. Um, we're gonna line them up next. We're gonna line them directly in, and we're gonna see what happens. What happens then? Um, and it's more like a peace sign. So you got your 180 degrees, and then you got your 120 degrees, all in the same. As long as you have a 6 or 12 magnet rotor, you could do that. Is it worth it? I don't know, man. I don't know how they stack up. Pretty much, in my mind, it'd be worth it. All right, so all the coils are parallel to the switch. And back them off because they have cores in them. Back them up a little bit. Do I have to move the switch? I might have to move it. I got another idea. Just to level it out, we're going to remove the cores. All right. Now, let's see what we get. I guess we're going to back them all out because they're not glued down. So, well, that one isn't going back. So I guess we move this one in. Here we go. 1.1 volts. It's really fluctuating right now. I don't know what's going on with it. We're going to go with the 180s. We're going to take the two 120s off. Oh. All right, so it looks like maybe the V or the, God, what did I even, it's directionally correct path here. So we're going to go with 2 going in and 2 pushing. See what happens now. And my switch might be giving out, so. Yeah, something's not working with the switch right now. I don't. Might just be built up. Build up. And this was happening before we came on. So I'm trying to figure out what the problem is. Ben trying to figure out what the problem is, because it works good when it's not. And it works at a very low voltage. But we're just going to turn it up to like 2.18. Now, this isn't going to get, this switch is not a high frequency switch. It will not probably get above 400 RPMs ever. But this is a, notice how we have two coils hooked up to the switch right now. I'm going to hook up the other two. Alright. These are the 120 degree coils. Alright, let's turn it back on. Look at that go. Alright, and that's 2.6 volts.
Can you sit this for 1 second?
Whew. Hey, what's up, everybody? How's it going? Oh, and then it'll stop. I'll just all of a sudden, because the metal in the switch just sticks to one another once it gets too hot. But this is now a 4 parallel coil reed switch. All 4 of these are hooked up parallel to the reed switch. You get some arcing there, and that's what's causing the metal there to kind of melt. Thanks, Joseph. So this is a combination of the directional coils and then the standard, I guess, coils, the regular, normal way. And that's 4 connections to the power supply. You got your black, yellow, and green positive connections. Each coil's got their own connection. And then it dumps into the switch, and you got 1 ground. And that just saves so much space on the table. So this is like 3 settling down, I guess. 315, 3 volts, 0.15, and then in between 0.1 and 0.4, 0.5. So we got highly fluctuations, and it's probably because it's like parallel setup. Not all these coils are exactly the same. They're just wound the same way. So they would fit together in that regard. They're all counterclockwise, and they're all from left to right. And then as soon as I get a hand free, I will hook this one up on a transistor. But yeah, I think this is awesome. You know, I made the homemade switch, and I like it because you can extend it. Um, the only thing that it's really not good at is high frequency. I mean, you can kind of make it good, but it's always gonna get to that top of the curve faster. The potential for the switch is less than, say, a transistor of a good type or whatever. MPN, PNP. That's 3.81. You can hear it go. All right, here we go.
Thank you.
All right, so this is cool. I like this. This is easily adjusted. You just unclip it right here, and you can add or take away any one of those. But I am going to, I'm just checking these to see what's hooked up. And then we will, I just want to make sure I get the right one. I think it's this one. Just checking to see if I got any lying around before I go and grab more. Alright, so we got base, collector, emitter, and I probably already have two of these taken care of over here on the board. Oh, and there's one right there. That's cool. Alright, so we got the diode for DC. To the base. Alright, let me check that. This can go here on the emitter. This is not a reed switch circuit anymore. That'll work. And then the collector pin will get a new clip and it'll go right to where that one was. Now I like to hook, the transistor up after the coils instead of before the coils because you get added resistance just from doing that. Oh. Gotta give it some power. But look at that. I'm probably gonna have to burn that. So if anybody that doesn't like me burning this stuff, please turn away. Actually, I don't have my lighter, which is okay, I think. I think it's long enough. Yeah, it's long enough. That's good. All right. Now the transistor runs a little bit more power than this thing, so I don't want to like combo those. They don't work together very well. And I hope that that one magnet is enough to trigger, or I'll have to get the other 4 magnet one down there. Okay, but we got options. That's definitely not working. So we're going to power down. We're going to take this off. And right down there at your feet, sir. I got it. Voila, another 4-magnet rotor. This one's got a little bit more permanent magnet power to it.
Sweet design.
Alright, so let me turn it on. Like right around 5. And you know, I might have to rearrange this a little bit because it's a bit longer. We might get some more speed out of it. You all right, bro?
Yeah.
All right. All right, sweet. Here we go. Just pop this one right here. Take this one. We'll put it right here. Now you do that maneuver so many times on your table, and you're gonna end up with this. Bingo. This will lower it a little bit. Line it up with the green coils better. All right, here we go. I don't know.
You said it looks like a roulette.
Yeah.
Yeah, it really does right in the middle there.
Oh, man. See, this is why I need to like drink a 5-hour energy before I start. Notice that the coil here is not grounded.
Aha.
Mayhem. Mayhem for mayhem. Right. Now when I plug this in, man, this should work pretty good. Alright, we're grounded. Here we go. I'm just trying to, trying to figure out what was wrong. It's definitely that. There it goes. Wow. Gonna try and draw 100 milliamps. Oh, it's not working? Oh, it's good. Oh, wait a minute. It was working. That's all in, man. 25.
I can definitely hear something.
Should I whip it one more time?
Yeah, it sounds like it's slowing down a bit.
Oh, we got amps.
Yeah. Nice.
We got 0.1 amps. 2.5 watts right there.
I think it looks sweet.
Let me get a look. Wow. Man, it's moving. There it goes. It's moving pretty good now. All those things that you forget. Wow, look at that. That looks sweet. Oh, that is awesome. Now, what I would do is I would clip this yellow one onto the reed switch, but I think 25 volts is way too much.
Yeah.
And it's going to stick, and then it's going to go up to like 20 amps. But this is cool. I had this one hooked up over here. And it was pretty cool. But this is cool, man. I can jack it all the way up and not worry about anything blowing up because the amp draw is so low. And that's
yeah, it looks so cool.
Oh, at least it looks cool.
But there's like electromagnetism going on here too, folks. So that would be 5 watts.
Yeah, at 0.2. Yeah. And it just crept up to 0.2 a little bit ago. So that's running smooth. This is a novelty, man. This is like clip it. Like clip it. I still want to do it, but I gotta turn this down. And then we're just running this coil right now. So I'll turn it down to 9. That'll work. That's working pretty well with one coil. Heck yeah.
Excuse me.
And that one's working. All right, they do have some small amount of duality to them. That's sweet. That's one hookup. I don't know what you'd call that. Just standard hookup.
I like it.
Nice. All right. And then we can go parallel. We'll go to one across. So if that's a 16, this is a 20. So I don't know if that'll work. I mean, it'll work, but I don't know if it'll function right. Hmm. So, should I hook up another one? I'm gonna hook up another one.
All right. Oh, imps.
Yep. All right. So that was hot. Too hot.
You saw it arcing.
Yeah. Wow.
I saw it hit 14 amps.
All right. So what we're gonna do now, just because we're cool like that, we're gonna disconnect these. That's pretty cool though. I like that. As long as it doesn't burn my house down. We're gonna test this transistor now. 9, 5. Tested it. Doesn't matter. Because I think you gotta turn that one up to like 25 for it to get any amps. But I think it's working right now. Well, it's not gonna squeak.
Okay.
That's what you were looking for. Because the coil's on the outside. I think it was working though. Yep, it's working. It's just easier to tell that it's working when the amps register on the power supply.
Right.
That's what I use as a benchmark. So neat. I like that one. This one, I think if we put a resistor in between each one of these and the reed switch, we're going to be gold. We got to figure out which one to put there though. So I was working with this earlier and I got to like 330 ohms, 330 ohms. And I think that's going to be a good place to start now. I do kind of want to get this figured out though. So it's a little bit of added resistance considering the coils are really fat. I don't think we would need all this if the coils were thinner wire and longer. A little longer. But since they're not those dimensions, need some added resistance. We're trying to cut the arcing down. And this does work. It works too well most of the time. And you gotta go really low on the ohms for it to function function well. All right. So with those, gonna need 3 more of these. I'm just dying to see if having them all with resistors will make a difference. And it's just a paper clip and a little length of 14 gauge copper wire for the switch. All right, let's give this thing a whirl. Yeah, see. We turn it up. You can see it is working. So my idea is sound, or the idea is sound, to put resistors there, because the arcing is gone, it's all the way up. But we need less ohms than what we have right now. So we're gonna go down to 220. That's pretty good. I mean, it's not great, but it is moving. And there's no arcing.
Hey, Brian, welcome in. Thanks for coming.
Hey, what's up, Brian?
You said cool about the coil orientation.
Yeah, it did. I mean, it definitely functions that way. Pretty good, too. I made a combination of both. So I got the orientation switch right here, and then, online, or headstrong is what I like to call it. Oh man, see, but we got 4 of them that we gotta do. So we're gonna do a put away phase. This is very tedious. I apologize for the tediousness to myself above all else. I'm all good. I'm not complaining. It's just that takes a little bit of time. Now, should we go to 220 or should we just go to the next level down? Like, yeah, I guess we'll just do 220. Because that was pretty good. It was picking up speed there at the end before I cut it off. All right. Surprised these are coming out as easy as they are. It's awesome. Another boon for the night. Resistors aren't hard to get out.
Hey, Peter, what's up?
Yo, my man, how's it going? What's up, Peter? One more to go. We're at 220 ohms for resistance
Things are good.
per wire. All right, so I'm just glad there's no front or back to these resistors. That you can plug them in either way, because I would flip if it was the other way, man. I can't really see those lines that well. All right, here we go. Homemade switch. Parallel circuit. Yes. And we are drawing amps finally on the parallel circuit, mind you. So this is good. These resistances are good. We might be able to even do a little less resistance. There's no arcing. Very little, if any.
Peter got a new oscilloscope.
Nice, Peter.
Oh, he was commenting on yours, but he didn't see that other one yet. All right.
Oh, mine. Right. This one.
What's up, Noah? Welcome, man.
Hey, Noah. I couldn't open your file, buddy. I could not open your file.
Oh, you're fine. You're just stretching a little. And then Brian said, "Oh, just fine tuning recommendation. I'll have you look at it." I think you may have done that, but
Oh, it's really good where it is. I've tried a lot of different positions, and with the positioning the way it is, it's pretty good. I mean, you can go a little bit to the right or left either way, and it's kind of right in the middle. All right, so
hey, Dallo, welcome, man.
hey. And the other thing is this is glued down because it's highly magnetic switch. I would call it definitely just a magnetic induction switch. It's got basically two reeds which clap each other when the magnet goes by. Okay? And it's just the simplest thing. It's not, I mean, it is essentially this without the package.
There we go. Yep. It was all blurry for a second.
Oh, my bad. Okay. Wow, it looks like this one is. This one might not be working right. Oh no, there it goes. Oh wow. So 3 magnets stacked is good for triggering. Well, the 1 magnet one is not good for triggering. I mean, it's not for what I have. And it's just, see, look at how well that works. We don't need to change it. So 4 magnet rotor with an amp funnel distribution, or it's more like an amp megaphone because it goes in the small side, out the large side. So the funnel goes this way and the amps get larger or have more room to move around. The current has, and that could ultimately slow everything down, that all of a sudden the current having more room to move around. But I don't know.
Dallo asked if you've seen the diagram that it,
For the magnets,
and have you tested the free moving magnet idea?
I have not tested it. It's going to take me a while to I don't use, I use Tinkercad. It doesn't have like exactly what I need to do that. But yeah, it's a sound idea. I really like it. I could probably print off a few things right now, but yeah, it's those ones where they just kind of rest there. That, you know, it's hit or miss really, even if you measure it down to the micrometer, you know, whether it's going to spin or not. So, you know, I'm just kind of dreading that. I want to do it because it's badass to have like each magnet have its own gyro.
Yeah.
That's awesome, man. That idea, I love that. So we're definitely gonna try. But like I've been saying the whole time, I eyeball all this stuff. This is all essentially just done with a compass. And that's it. Everything else comes from me willing it to be.
Awesome.
And I mean the software that I use, Tinkercad. Literally, the only thing that I use to position everything is the compass. It's 2 rotational compasses. You get your X and your Y. I don't know which ones are that you're rotating, but X, Y, or Z. um,
You said fair enough. Yeah.
and you see, I made one, a rotor, just recently, and then the copper infused PLA. I'm going to put it. There it is. All right. So, and I'm going to have to do a print without this crap. And see if it'll just
Okay.
print because.
Let me see if I can get a close up inside of there before you put it in there. There we go. So there's divots.
Yeah, in the top and the bottom. And then this will rest in there like that. On this model, it'll rest up and down. It won't rest on a 45 because the divot is entered, and that's the way it is. Nothing that you can do to change that on this model. But see, as you can see, I'd have to print a new Utron because the tip of this one is rounded off.
Yeah. Okay.
And you want them to be pointy, and it's just the tip rounded off, or it'd have to be a perfect fit. And then, you know, if it's gonna, I don't know. And then I was thinking about more magnet stators, and coils on the rotor. or basically having the stator, what is normally the stator on the outside, spin, and have the inner part, the rotor, be stationary. So just kind of flip the two. And this one's made for 2 magnets, and I didn't hollow out the front because I figured, you know, it's magnetism, it's going to go right through that. I mean, might be impeded a little bit, but not enough for it to really, you know, I just usually put a hole there so you can see the magnet, but you don't need to. Yeah, man, this is a good design, I believe.
Nice.
For that idea. But I mean, there's already like 3 or 4 ideas I'm wrapping my mind around right now. All right, so, oh yeah, and this one is definitely heavier than the other one that's down on the ground. This was 33% infill, and the other one was 25% infill.
Okay.
But that's definitely the idea, and I'm going to print another Utron, but like I was describing in one of my videos how this stuff has kind of got a rubbery texture to it. I mean, it's grainy at the same time. I think it'll work. It'll end up working just fine. But it might grip the divots in here more than I want it to. But I think the more it's like sits around, the harder it gets. I mean, the less, because it's like, I don't know how to describe it. It's like blacktop almost. The plastic in it. The PLA. Even though it's only 40%, I can feel it in there. Because I got 100% aluminum one, and the texture is way different. Definitely, I mean, it probably will work, I guess. I will definitely try it.
Hey, ICT, welcome in. We appreciate that. We love electronics as well, and we're doing this with no background in electronics, which is awesome.
Yeah, it's like virtually we come to the table every night with a fresh start.
Yeah.
Like, what did we do last night? Who cares? Let's move on. No, I'm kidding. I'm joking. But I
And
love
then
this.
Dallas sent that. In response. Oh, my bad. There we go.
Oh no, it's definitely a good design, man, and I think our, let me think here. Let's call you by name. I need to see the name. Dollarap. Yes, I think it's a great design, and it would definitely work if we can make that, you know, make it work. It's a good design. Should function. Will they all spin all the time in all directions? Probably not. But I mean, that's not the point, right? Because normally in these motors, the energy is dead on, or it's designed to be dead on, so you can replicate, rebuild, mass produce. You know, it's designed to, when you turn it on to 10, it goes all the way up. When you turn it on to 1, you know, I don't know what kind of, like, point I'm trying to make. I'm very, like, dehydrated or something.
It's all right. We got a question about any progress on the gyroscope.
Not really, you're talking about the one with the spinning things? Or the
Yeah.
bigger gyroscope, like, because I got two gyros over here. And I was dismantling one to try and put a transistor in it, which I probably shouldn't have done. Because it's not built like that. It was done. And then I tried to take it apart and put it together a different way. And I haven't even picked it up since, honestly. It's kind of discouraging.
And then ICT asked, what was your idea behind that? I don't. Can you remind us what we were talking about at the time? Or were you just.
What? The gyroscope? Ah, what? What are we talking about?
I'm just making sure ITC was asking about the gyro. Do the motors run by themselves? That's what he was asking about.
No, they run on DC power.
Okay.
Now with SG circuit, you can run this motor, and then this motor can run this motor without needing any extra power connections or drain on the power supply. So I think that's pretty cool. And I could honestly, without, it's probably not a good idea, but all I need to do really is clip the collector, put a diode on the end of it, and then I can run this motor. We gotta hook up a transistor. It's not hooked up for a transistor.
Right on.
And I don't need to do anything else. But you're probably gonna end up having a spike that's gonna wreck you. So it's a good idea to put your light in, your Schottky in. And yeah, just.
He says, I see that.
But it will work without that stuff. It's just a continuation from the collector. So it's virtually, the power goes in, goes around the coils, goes to the collector, and then you just extend that. So it won't be the total amount, but it will be close to the total amount that's coming out of this. Each one of these motors costs power to run. So if you're working with batteries, I guess there is a way through spikes that you can end up with more power than you started with. But seriously, doing that really puts you in a box, because you can't charge those batteries any other way ever again. So they're totally dedicated to this, and that means just do it for as long as you can. And that's okay. I mean, I guess that makes sense to totally dedicate some batteries to this, right?
We got an offer here.
Oh yeah, man. Straight up, dude. If you could dollar it. Oh man, yeah. That would be so cool. And then yeah, I got a great printer, so that.
And then Sasa asks, if you remove the second rotor, would power consumption decrease?
Yes, by 0.1 to 0.2 100 milliamps. So this one runs on 0.1, and this one runs on 0.2, 0.3. So yeah, if I take all these off right now and disconnect this one, that will go down to 0.1, 0.2.
And yes, we do have a Discord. Do we have your email, Dallo? Okay. Yeah, in that case, I'll send, I'll just figure out what your email is and I'll send the link through. Yeah, you can do it right now. Or, well, I still have to go get his email. unless you guys can work that out.
Alright, so I twisted the coils a little bit.
Michael, you should have came in about 45 minutes ago, man. Sorry.
Oh man, yeah, we blew it up for sure, man. We had a little fire going on the table, but it was inside the switch, so we're all good.
There was an arc right here, and about 10 amps went through it.
See,
But safety first, safety first. Indeedy deedy. So when you're doing this, you're redirecting timing and gaps.
I was just changing the orientation to shift the magnetic field.
Okay.
Yeah, that's all. And now you can see that it likes to push on a face, north or a south face. So when you're working with the cube magnet, you're going to want to put it in the slot sideways so the north or the south is facing to either side when you do the orientation shift. You want to shift your magnets to face either way, because when it's facing out like this, you want it to hit the face, whatever orientation it is. You do want it to hit the face of the north or the south face, not a half face, and that's what ends up happening when you're doing this without changing the magnets themselves. So, I mean, I already noticed a slight increase in performance just from shifting them back to normal.
Brian said sometimes both with the pickup coil.
Sure. I mean, that's probably right. Except I've never understood the exact like a pickup coil. What does it do? What is its purpose? Here, I'm gonna throw it back at everybody. What's going on here? What is the purpose of a pickup coil?
All right. Peter said 0 point is tough. Oh, and then he said gravity is free. I like that.
Gravity is also constant unless manipulated. So everybody feels the exact same gravity all of the time, unless you either leave the atmosphere or you manipulate it somehow.
That's true, and there are some universal constants that do not change.
And gravity is not a universal constant because it only applies to the center of gravity, which is in, the Earth.
Yeah, depending on how much mass is around you.
Right.
Yeah.
And because out in space, it's cold. It's cold in space. You get solar radiation, but it's like 0 G out there, man. It's freaking ice cold.
Oh, for sure. I want to see if.
I mean, everything that we experience inside of this atmosphere doesn't exist anywhere else. Anywhere else. This is, and there's other planets similar, probably, but nothing like this. This is awesome. Gravity is awesome. This kind of gravity, this amount of gravity, is why we are here. It's the only place we can exist. Any other place would be, or floating away, or whatever. Even it would just be totally different if it was totally different.
Thanks, Noah. We'll see you later.
See you, Noah.
Is the inner disc permanent magnets?
Yeah, the inner disc is the permanent magnets. I was thinking about making an outer, like a ring, and having the middle be like still, and like have an outer ring. Peter had a great suggestion the other night about like having it just dangle on the top.
Yeah. Nice one, Peter.
And then kind of umbrella over, like so. That's how I got the description. I mean, that is a bomb. I go follow through with that, man, and I'll see what I can do with it too. Cause that's a great idea. Um,
Thank you for that, Peter.
yeah.
And Michael, yeah, it's iterations. We're learning as we go. So it's in the plans for show.
Oh, I've done that, and I don't have anything to time that properly, Michael. I have nothing to do that with, and I've done a lot of experiments like that with the inner and the outer permanent magnet. I've done a lot. You should look at them actually. I had, let's see, like 9 toroids on the outside, and then I had 12 magnets like this on the inner rotor.
Oh, yeah.
And it worked. It works, but it doesn't run like this.
That was
It'll-
before my time.
It'll stop. It'll definitely stop. But it'll run for a while.
Awesome.
Even these will stop. The power well will eventually run dry if it continues to run like this. I will run out of money and the bill will not get paid, and then this will shut off. And when that shuts off, these are going to stop moving.
Economics 101. Yes.
Now, if I had a battery and I was using a battery, it might say it lasted until I died. Say I'm kept up with it and I made it run until I died, and then 6 or 7 months, 8 months, 9 months, 2 years after I'm dead, these will stop. No matter what. I don't, I, and you know, I would be more, I'm like a giddy school kid if somebody would show me, even be able to even begin to show me something that's going to spin forever. Okay? I mean, I have got 40 years left. Okay? Maybe. And that would be a good start for forever. You know? 40 years. Let's see if we can make something run for 40 years using whatever you want. If you can do that, that alone in and of itself is an accomplishment, but it's not free energy and it's not perpetual motion. I mean, the closest thing this globe has to being to perpetualness is us, human beings, and that's as close to perpetual as we're going to get. And we could just wipe ourselves off the planet at any given time. It's not hard, especially in this day and age. The nukes haven't gone away; they've just gotten better and more quiet about it and everything. They're not gone. I'm not thinking about it really, but it's like,
Double O.
hey, what's up, Double O?
Some nuclear reactor's been going for 70 plus years.
That's good. That's a good example.
Yes.
But is that going to run forever? No, it'll melt down before forever comes. I promise. We're going to run out of water before forever comes. But I don't even know, man. Some people think this planet is made out of water. I don't think that's true, but I think it's part of what it's made out of.
Nice.
Heck yeah. And yeah, the last 20 minutes have been me expressing myself. So, all opinions, that's all I've been saying for the past 20 minutes is my thoughts on certain subjects. So, I haven't looked at the news, I'm not quoting anybody, and just what I know to be true. And if the nuclear reactor has been running for 70 years and the nuclear warhead is still ready to go, you know?
And Dello, I have heard that too.
Oh yeah, I'm sure that the water has seeped and eroded, and yes, and I heard that there's a movie out there about the trench, and if the trench is just like the highest level of a subterranean maze of water.
And then, yeah, double O, like nuclear. Definitely clean, zero emissions, the water part, but they're costing themselves out. They got to work on the price of it. Is that cheap?
Oh, that is so smooth. What's the power at?
20.
So I think we can even decrease the ohms a little more. 'Cause I'll do that.
Yeah, that would be cheap.
What's that?
You said 12-volt battery into water can split the gas. DHHO. All right.
Yeah, man. Just keep track of all that stuff for me, will you?
Mhm.
Because I don't know. I just know that yeah, man. That's it.
Thanks, Dallo. Yeah, we'll send you the Discord link. Have a great rest of the day.
I think that we should invest in more city-sized batteries.
Yeah, I agree.
And really, they're just the size of like a shed on the top of a skyscraper, but they're they're like I don't know, as big as this room maybe.
I think they're getting them to like shipping container size.
Shipping container. There we go. Now that's a battery right there. I wouldn't run my pulse motor on it, but it could probably power however many homes or store how much and however much energy. But yeah, consumption is real. Um, so like even if you have a perfect system that you know fills itself back up, man, you hook up anything to that, like, well, I don't know, because the collector thing, you can make a long train, but even with that, by the time you get to the end, you are virtually no power. So yeah, I mean, I don't know, man. Could I run my entire house of appliances, like my blender, my fan, all that good stuff, off of this pulse motor using SG? Can I do that? I don't think I can do that. I think that I can probably hook another pulse motor up. I can definitely hook a light up, um, like an LED, big LED, 100-watt LED. We can hook LEDs to it all day long. And I'm not talking like, I'm sure there's something you can do if you're making enough power to convert it and relay it and regulate it so that it'll run, a washing machine. But, as is, you can't, it's not a plug and play, man. You can't just plug it in and have it work. I've tried. So, this isn't just a plug and play. You gotta kind of know stuff or at least, ask questions about stuff. And we tried to run the fan the other day with SG. It did not run. And I'm willing to, put the fact that these coils are really small. They're only 911 turns of bifilar 26 gauge, 30 gauge. And those are the coils I was using. All right. Yeah, I wanted to run the other rotor, but it's just not going to happen. I mean, the magnet strength is literally not strong enough to move the reed switch with just the one flat magnet. I mean, it'll move it a little bit. I wonder. since we made some stabilization changes with the resistors, I don't know. Yeah, I'm tired though. I'm not gonna mess around with this too much. Yeah, I'm digging how well this is working though. It's not totally, what do you call it? I don't even know what I was gonna say, man. All I know is it's working pretty good. It's not a total piece of junk. And I've tried up, down, sideways, different ways of making these things. Same basic principle though. And they are never going to be like this high frequency. It's not going to happen. It'll get clapping and then it'll get to a point. I mean, if we get the resistance right and there's no arcing and it doesn't stick, maybe. But I just.
It's like the solution will come to you in your sleep.
It usually does. If I manage to get any sleep. I do want to try this. I want to hook up this with the resistance on there. So let me do that. It's gonna fry. I have a feeling that it's gonna fry the resistors, all of them at the same time. But we will see. Are you hiding behind the vacuum? Yes. Okay. All right. Are we ready? No. No, we're not ready, but we're gonna do it. I just want this though. I don't want to destroy this transistor. I'm sure it can handle, it just doesn't have the resistor on it, so it probably won't be able to handle it without that. So it's not enough resistance. All right. No, we don't need all this. Green. So now we don't have to go all the way up to obscene amount of volts, like I think it was on 89 volts. Looking good so far at 31. 41.
There it goes.
Is it arcing?
A little bit.
We'll just let it ride and see how much this increases in speed.
I can see just a little flashes every now and again.
Oh, there goes the resistors. Yep, there goes all the resistors. So in order to go above 25 volts, we need now more resistance. Sweet. That was cool though. I don't think. So, since we're going up to 63 volts max, should we go up to like 1,000? Or 680? 680? I don't know.
What are the resistors for?
To reduce the arcing, and it works wonders. So, it does indeed. And then if the arcing is reduced, then hopefully the switch won't stick, and then we can increase the voltage and the speed. That's how this one works. You got to increase the voltage to increase the speed. And I just burnt the whole regime. Every one of these that it was just hooked up is toast. They're all burnt out. That's why I'm switching them up. Oh man. I haven't had anything to eat today. Right, here we go. Oops. So this is 1,000 on each. Each one of these coils is hooked up parallel to the reed switch or the magnetic switch. So each coil gets its own resistor. 63 volts. Might even be able to use the thing now with 1,000 on each of them. See, notice though there's no arcing, but 1,000 is a little much for 63.
It's like why the cameraman moved back.
Oh, we're frying them. Oh no, we're not. That's all the smell.
It's up all the way.
Yep. So you either up the voltage or you reduce the resistance at this point because this is the vehicle's max speed.
So what kind of resistors are on there now?
Those are 1K ohms, 0.5 watt tolerance, or I think it's a 0.5% tolerance, something like that. Really just weak.
And the other ones are 680.
Before this,
Mm-hmm.
I think they were 220s.
Oh wow. So what's the next level then?
The next level up,
For transistors, the ones that'll work.
you mean resistors?
Yep.
What do you mean the next level up? We've got to go down. I think it's 680.
Yeah, that's what I was trying to say.
All right. Or we hook the voltage back up.
Yeah, no, I'm good on that thing.
I'm good on that thing. It was squeaking. Oh my God, something's not right. I feel really dizzy.
Oh, that's the food you haven't eaten.
Yeah.
So we'll another half an hour. We'll go for 2, unless you can. We'll test to see how you're feeling then.
All right, so we're gonna do one more switch out. So we want to go 680, or we want to go 470.
680.
680.
Because 220 burn up pretty quick. Need like 10 watt tolerance.
No. No, these are working. Yeah, I mean, even with the 10 watt, 5 watt tolerance and 5% tolerance, they still burn up. They do, man. It's. And then I got those shunt ones. They're. I really have to focus on this though. This one right here.
No, we didn't get a chance to go over to the computer yet, no.
Oh man. No arcing as that I can see.
Let me try and get a close up on it. Okay.
I smell them burning though. I smell something. I don't see they don't look like they're burnt though. There are a lot of burnt ones here, but the ones that are hooked up are not burnt. They're getting hot though.
All right. And there's no fan, so I think that was the old smell, or you think?
I don't know. I don't think they're on fire.
Oh, I smell that now. Yeah. All right.
No, they're definitely working still.
Cool.
But I do smell, because the ones we just had hooked up got burnt. I know.
Right.
No, wait a minute. I don't even know. I do smell them. Something, but they're not freshly burnt. Because right up in there, I would smell that. I don't. But I do smell it occasionally. I think it's just lingering. All right. So I have another idea. We're going to hook transistor back up real fast. And we're going to run it with some more voltage to it. Of course, we're going to start at 30, 25. The only problem is we don't have the amp reading, and I don't have an amp meter. That's running pretty good. That's good. That's good. All right.
Can you move the switch to behind a pulse coil?
Oh,
Could give. Okay.
it's glued down. No, I can't. And when you line it straight up with the coil, it doesn't work either way. So,
Is the second one offset for a reason?
what second one?
Ghetto mining asked that.
From
which-
where's our point of reference? What's
Which
the
one?
second one?
Which one are we talking about? Sorry. The one closest to me. So this guy.
This one is the last one.
Are they all onset or are they offset?
They're all onset to a. It's a peace sign motor.
Yeah, that's right. The peace sign motor. And they are onset.
Mm-hmm.
Okay.
Now, if it was an offset coil, I could probably put this in the middle of it, and it would work really well.
You want to jump on the chat?
No,
Okay.
I don't feel well at all. I'm not getting on the chat.
You guys can jump on the chat though.
Yeah, go for it. It's open house. My stomach just is not right. I mean, I'll probably, if you're there when I'll check it out later on tonight. If you guys are there, I will definitely chat with you.
Oh, okay. He said by offset, I meant not on the XY axis like the other. Okay. So what's the benefit of having a peace sign as opposed to a perpendicular?
I don't understand.
Is there any benefit to having them like this instead of like this?
This is 120 degrees, 120 degrees of separation. This is 120 degrees of separation. This is 120 degrees of separation. It's just a 120 circuit right there. And then we got our 180 degrees right here. It's 180 and 120 combined. It's
Right.
It's both of them.
Got it. Thanks for stopping. Thanks for subbing, Michael. Thank you.
And that's why I think it's all right. I mean, we could always take this one out and have it be a straight 120,
Right on.
just like that. Of course, we'd have to rearrange the wires to do it for real, but yeah, we can do that. Or we can do a 180 and remove those two. And then they'll both work with this rotor. And probably the reason that it doesn't look like anything you've seen before is because I don't replicate. I do not replicate. I do not take somebody else's work and try and do the same thing. I will always put my own spin on it. I will always just do it how I will do it my way. Your suggestions are very helpful, and if they're good and they correspond with what I'm doing, they'll probably get implemented into what I do.
Yeah.
But if they're off the wall and like we're bouncing swamp gas in Venus and light off of that, and then we angle it from over in Saturn's rings back to us, and we're gonna get perpetual motion. Nah, I don't want to hear anything about it. That's funny though. I mean, if it's a joke, man, I'll probably listen to it and I'll laugh, and then we'll have a good laugh. But if you're coming at me like that's for real, I'll be like, yeah, man, why don't you make a video about that and I'll watch it.
He's like, but what if that were actually true?
Yeah, make a video.
Yeah.
I'll watch it. And I'll just like and subscribe, and then yeah.
Yeah.
So it's true.
Rock
I want
and
to see
roll.
it. I do. I really do. Whether it's true or not isn't really the issue. I have a very scattered brain, and I have to remain focused. So it has nothing to do with whether it's true or not. It has to do with whether it's corresponding to what I'm doing.
That makes sense.
Because I'm trying to stay focused. I'm not trying to be in the clouds right now. I'm trying to ground myself because I have 2 kids. I have to start making some kind of money. This is kind of starting to take off a little bit. Memberships are a good way to show your appreciation. Brand loyalty is another good way. So you get a membership and then it rolls over and you've now got 2 months in, you get your badge. That's awesome too. It's not just like, you can do whatever you want, but
And then free 3D prints.
yeah, get your master's level, and we have to correspond at that point, but you get a free 3D print off my printer. Those are the dimensions, 8 by 8 by 8. So those are the dimensions you have to work with. And it doesn't matter what it is. It can be a pulse motor, it can be a sculpture of some kind, it can be
Figurine.
of King Kong,
Mm-hmm.
So yeah, think about it, or buy your own printer. That's another way to do it.
Indeed.
Eventually it'll probably end up being cheaper for you to get your own, but that's neither here nor there. I have no shame taking your money from you.
Jeez.
More the merrier, man. I mean, it'll not likely. I don't even know, man.
Well, we want to have
money always goes into this.
right. We want it to be a self-funding thing.
Yeah, really.
That's what you're getting at.
No, but seriously, I mean, if you walk into it feeling bad about asking people for money, I mean, part of me does. I mean, it's human nature to not want to like have to ask people for money. But I think that it's okay. It's all right. Especially in this day and age, there's a lot of money floating around out there.
Yeah, this is like the first time we've actually done it.
Huge amounts of money floating around out there. I don't know where it all fell. Fell down off the tree, but there's lots of money out there, and I'm gonna try and get some of it.
It will definitely work on the approach, but yeah. We got the
No,
Patreon
this
set
stuff,
up.
I mean, yeah, I mean, this stuff is gonna get me a little bit of money, but I'm not talking about this being my bread and butter.
Oh, straight up.
Straight up, man. I'm talking about, getting a small chunk for me. That's what I want. This is just one avenue, direction. And because I didn't even start really doing any lives on this stuff until after I reached a certain point. I already had about 2,000 videos out before I even started doing lives. So if we're trying to stack up, you can't stack me up next to anybody else because they do it their way and I do it mine. And you can't. Don't, please. I think there's a lot of awesome channels out there.
Are there any high-speed motor 3D prints available?
That I've done.
Maybe I could book it onto a file. I have to motorize it.
All right, I gotta try and stretch out real quick.
Yeah, we have talked about that. No, for sure.
Talk about what?
Selling rotors,
Oh yeah.
making kits.
Yeah, not really kits. I mean, there'd be a very basic kit, and I don't think it would look anything like other people's kits.
Or like maybe getting.
'Cause I've checked out the kits, and yeah, I could probably do them for less money, but it wouldn't look like I am, the electricals. I wouldn't be using a breadboard, things like that. I'd throw a transistor in there, you get your rotor, you get your magnets, maybe just a rotor, maybe just a rotor, a couple bearings, do the magnets on your own, because that's a lot of money. Magnets.
Magnets are the most. Maybe we can find something with the magnets. Points.
Sorry?
Find something to point someone to people.
Yes. Oh man, my buddy.
And,
There's a.
so we can figure the magnets part out. And
No. For my designs, we'll figure out magnets for you. For your designs, you got on your own for magnets.
got it. Perfect.
It'll all add up. Okay, so if I don't buy you the magnets, I will give you the link for the exact magnets that'll fit in the slot,
Right.
and you can buy them. It all depends on how flush the pocketbook is, but the rotors definitely, and naturally, if I don't send you the magnets, you're obviously going to pay less. But you'll get the bearings. I might even put the bearing in for you. 2 bearings. You get one on the bottom, one on the top. All these are for 1/4-inch shafts. Okay, and the 1/4-inch diameter shaft is what all these bearings are. So that's all I have. So that's all I'm sending. I don't mean to sound like a total dick, but I am. And I try hard, very hard not to be. I'm just, and then I'll give you a coil. So you get a coil with that.
Yep. He just said that.
And a transistor. I'll give you a transistor. Now, a complete set would probably be $150.
The power supply and everything.
No, you don't get a battery.
Battery, got it.
Power supply, dude? We're not shipping power supplies.
Can give links.
Yeah, I'll give you a link to the power supply. Give you a 9-volt battery in there.
Maybe we can have something where they choose.
No, man, you gotta listen, bro. You gotta think about money.
Right, if they choose power supply, then we give them the link. If they choose battery, then
I'm gonna throw a battery in there.
we'll give them the battery.
Well, they're only gonna get. I'm gonna give them the 9-volt battery. It comes with the kit.
Got it.
You don't have to put any check marks or anything. If you want, I'll send you. Connection to the power supply. Yeah, I'm really tired. I'm tripping over my tongue, and he's making it.
All right, let's do this. I have a tech question. He has magnets face out on the normals. Is there any benefit, let's say, putting them in line, centrifugal axis wise, with their magnet faces pointing north, south, south, north, north, south? So the same poles face. Makes sense. I didn't read that smoothly.
No. There is not a coil or a setup or a transistor or anything on this table that is going to make these go above 1500 RPMs. I have subconsciously wound all this stuff to keep me within 700 to 1500 RPMs. There's nothing you can do. I will try anything you want. There's nothing you're going to be able to do to get it go faster than that.
Built in.
It's a built-in safety mechanism.
But if we can afford one of those cages, one of those Faraday cage or like a padded kind of thing, yeah, we'll do it.
No.
Just playing.
Man, yeah, I don't know what's going on over here.
I'm just joking, man.
I'm not really, this right here, this satisfies me, okay? This speed right here, this works for me. I don't need to go faster than that.
He was like, it was just a thought on the magnet arrangements, how it works with the motor.
It's a great thought. I didn't get the good relay, but...
Yeah, I read it bad, so
Now what I want to do is I want to make a stator in the middle with the coils in the middle, and then I want to make like armatures that come out at various degrees of separation, right? With either permanent magnets or coils on the outside, or permanent magnets on the outside, coils on the inside. Person suggested you do permanent and permanent. I like doing that. I've done that before. It's really awesome. How long it'll spin for. It's good. And yeah, but all your like mechanisms where I was going to be like changing up the different, moving all this stuff, that's probably not going to happen. With the permanent magnet thing, because I know that involves, for it to run properly, for it to go in and out, and that's why I suggested making a piston,
Oh yeah.
because you have to pump it, man. You can't just let it stay there, or it's gonna stop every time, man. It's just every time it's not gonna work. You have to have. There's got to be some kind of motion from either side. And as long if that motion is more constant, like a piston, like when you know how it will work, the magnet will come through, push it out. There'll be a magnet up here at the top of the piston. It'll push it back in, and it doesn't even have to go all the way in. And the faster it goes, the more responsive that mechanism will be. And you can put as many as around here as you want. You can make them whatever size you want to make them. It's just a basic concept of a magnetic piston. They got to be really greasy though. Can't have a lot of resistance.
Right.
And then just pop, 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 and then you'll have an automatic way to get your permanent magnets on the outside to go in and out. And I say that's a win. You don't have to have them both going in and out. Thank God. The inner and the outer.
Yeah, I like thinking about that idea a lot.
Now I've asked 2 mechanics to it's feasible. One said yes, and the other hasn't gotten back to me yet. Because it's virtually going to be like a piston in a car. Exactly the same type of mechanism without the internal combustion. Use magnets instead. And I don't know exactly how it would, so far it's just an idea, and you get how to set it up exactly. I mean, probably on off like it is right now with 6 magnet rotor, or 6 positions and 6 magnets in. So you have 6 empty slots, 6 magnets in. Or you'd have 12 magnets in. And then it would push, and then this one would push, and by the time it comes back down, it's already pushing up again. It would work. I don't know how far it would go, but it would definitely function for a while. Depending on how far I flicked it. What's up?
He's trying to describe something, and I'm trying to do it. But it was supposed to be, what if the magnets were arranged south, north, north, south?
Yeah, I've done some work like that. Actually, it was a 13 magnet rotor. So it had 13 slots in it. And problem with 13 slots is that the symmetry is 1 and 13. That's it. So you can either do 1 coil or you can do 13 coils. Our onset, could go all the way around, but I'm just talking about for the idiosyncrasy of the whole thing. But anyway, what I did is I put, 1, 2, 3, and then the third one, I forgot how I set it up, but it was, the third one was going to be whack, or the fourth one was. Anyway, there was more spaces between the last magnet and the first magnet than there were between any of the other magnets. And then I offset one of the coils to hit, after it would go all the way around, it would hit that third one. So it would hit 2, 2, 3, 2, 2, 3, 2, 2, 3, 2, 2, 3, and that extra kick would actually increase the performance tremendously. Like, it was great. But they were all north facing. I just what you described there kind of made me think of that experiment.
We've been on for 2 hours.
Yeah, I think I need to get a bite to eat.
Me too.
All right. Well, thank you very much, ladies and gentlemen. I find this stuff extremely fascinating. And I like the fact that I've made this entire motor pretty much with my own two hands.
Yeah.
From the switch to the coils to the rotor. The only thing I didn't make is the shaft and the bearings and the magnets. So that's cool. And same with this one, except I didn't make the transistor. Here I kind of did make the transistors, but over here I didn't.
We got a good knowledge. Thank you. Great info. Thank you.
Thank you, thank you. Really had a great night tonight. I appreciate everybody stopping in. Yeah, drop a super thanks. The heart on the thing, man. Drop me a super thanks, man. I love you guys. Peace out. Have a great night. I'll catch you on the flip. Bye now.